Hi, we are from Group 9 of B1 Group, and today we are presenting Week 3, and my name is NURUL, NATASYA, NAJWA, BINTI, ZAHARI, and my number matrix is A24A3265. And I will present the problem statement on inefficiency and regulatory fragmentation in global cloud auditing systems. So first, the shift to market-oriented cloud computing, IT has moved from a product-based model to a utility-based model, where cloud computing provides scalable on-demand resources. However, there is a gap between the rapid elasticity of cloud system and the slow, manual nature of traditional auditing, leading to inefficiencies. Next, the crisis of traditional auditing current systems rely on manual processes, making them inefficient and difficult to scale. They cannot effectively monitor large infrastructures such as Amazon Web Service with its global multi-region environment, resulting in limited visibility and control. Then, moving on to latency and real-time challenges, cloud environments generate dynamic and high-speed data, but manual auditing cannot keep up, creating delays and operational blind spots that increase the compliance risk. Next, regulatory and security fragmentation. As cloud services expand globally, organizations must comply with different regional regulations. Traditional audits often fail to address this specific requirement. The lack of infrastructure as code also leads to inconsistent security configurations and higher risk of human error. Finally, there is a need for an AI-driven AWS-based solution introduced as Quick AWS. This approach uses AI and automation to improve efficiency, applies dedicated local zones for regulatory compliance, and integrates AWS outputs with infrastructure as code and serverless computing to enable automated, consistent auditing.
Hello, Assalamualaikum. My name is FARIHEEN bin NORHISHAM and my matrix number is E24A3175, and now I'm going to talk about access chain VUCA context. Okay, the first one is volatility, which is the landscape which is characterized by rapid shifts in demand and technological requirements. It splits into three, which is the dynamic market demand, resource allocation and pricing, driven dynamically by global market demand and quality of service requirements. The second one is rapid elasticity. The infrastructure must leverage rapid elasticity to scale compute power for demanding workloads like generative and agentic AI. And the third point for volatility which is AI-powered efficiency, which is to combat volatile power needs. Generative AI is used for predictive smoothing to reduce unused or underutilized power in data centers. The second, which is uncertainty, which is unpredictable factors in performance and global regulation create a need for constant adaptation. The first point for uncertainty is performance variation, which is there is inherent multi-tenant chaos and performance variation across distributed cloud environments. The second point is regulatory threats, which is increasing global demands for strict data residency and digital sovereignty create significant regulatory uncertainty. And the third point for uncertainty is future AI demands, which is the infrastructure is being built to support the massive yet still evolving compute demands of next generation autonomous agentic AI. The third point for nexus chain VUCA context is complexity, which is the physical and digital scale of the operation involves intricate multi-layered system. It is about global infrastructure layering, which is the system relies on a three-layer model, which is infrastructure as code for programmatic orchestration, a node network of 123 availability zones, and a 20 million kilometer terrestrial subsea fiber backbone. The second point is theoretical harmonization, which is the strategy requires unifying diverse frameworks such as the Berkeley view. And the third point is multi-regional compliance, which is the neutralizing regulatory threats requires the deployment of dedicated local zones to ensure compliance without sacrificing agility. And the fourth point is ambiguity, which is the transition from traditional models to modern cloud utilities creates blurred line in service delivery. The first point is utility-based shift, which is there is a historical and ongoing shift from localized on hardware to scalable metered utility provisioning. The second point is resource abstraction, which is the visualization and dynamic orchestration to enable the seamless abstraction of physical resources, moving away from static siloed data centers. And the third point is market-oriented exchange, which is to compute the transform into a trade utility where the traditional boundaries of hardware ownership are replaced by dynamic service level agreement negotiation.
Assalamualaikum and hi, my name is NURUL ALIA MAISARAH binti MAZMEE with number matric E24A3323. Now, I will explain why innovation was needed for a next-gen cloud system, particularly in modernizing infrastructure as a service using AWS data and AI infrastructure. For many years, businesses relied on premise IT system. This setup came with heavy upfront costs for hardware, constant maintenance expenses, and the burden of over-provisioning. Companies often had to buy more capacity than they needed just to avoid downtime, which meant wasting valuable resources. And when workloads fluctuated, this system struggled to keep up. Expanding capacity was low, cumbersome, and often too late to meet the demand of fast-moving markets. At the same time, the world was changing. The rise of big data and artificial intelligence created a new set of requirements. Suddenly, organizations needed high-performance computing power and vast storage capabilities. Traditional systems simply couldn't process massive datasets efficiently. Businesses needed real-time analytics to make decisions quickly, but legacy infrastructure was too slow and too rigid to deliver those insights. Globalization added another layer of complexity. Companies were no longer confined to one region, they operated across continents. That meant they needed systems that were accessible everywhere, seamlessly, without the limitation of physical infrastructure. Cloud solutions became the obvious answer, offering flexibility and scalability on a global scale. Security and reliability also became non-negotiable. In a digital economy, data is the lifeblood of every organization. It must be protected, always available, and resilient against disaster. Traditional systems carry higher risks of downtime and data loss, while cloud infrastructure offers built-in redundancy, disaster recovery, and peace of mind. And let's not forget the competitive pressure. In today's fast-paced environment, firms must be agile, scalable, and innovative. They need infrastructure that allows them to experiment, launch products quickly, and respond to customer needs without delay. Without innovation, companies risk falling behind. This is where the next-gen cloud system built on AWS comes in. It represents the innovation that was needed in infrastructure as a service. By moving beyond the limitation of traditional IT, NetSystem delivers improved efficiency and reduced costs. It supports AI and data-driven applications, enabling businesses to harness the power of big data. It provides scalability, flexibility, and global performance, ensuring that organizations can thrive in a connected, competitive world. In short, the move to cloud infrastructure wasn't just a technological upgrade, it was a business necessity. NetSystem Cloud System on AWS empowers companies to innovate faster, operate smarter, and succeed in the digital age.